Hey everyone, today we are going to talk about this tiny little equation called logistic maps and how does it produce such beautiful structures as you see here. Moreover, we'll also be talking about what does this have anything to do with free will. This is a question that's bothered philosophers since a long time, and I'm sure this must have come to you as well. So, talking about that equation having to do with free will is, of course, a big claim. So, let's just dive into what does this equation really mean. And just as a quick reminder, this equation is known as logistic maps. And as you see, this equation is very simple. Value of x at n plus 1 time is determined by value of x at the nth time and this parameter called lambda. So in other words, you start with some starting value of x called x0 and you simply iterate over different time steps to get x1 and then you use it to get x2 and so on and so forth. For example, if you start with x0 as 0.023 and lambda as 1.2, this is the sequence of values you get. Da 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 da. For lambda less than 3, x always approaches a fixed point no matter what you start with. So in this case, you can see over 50 iterations, x started from 0.023, but eventually after say 20 or so iterations, it reached a fixed point and it didn't change from there. For lambda between 3 and 3.5, you can see that x starts oscillating between 2 points, in this case 0.8 and 0.5, which is super interesting and I didn't expect it to oscillate between 2 points. So what do you think what happens next if lambda is above 3.5? What happens to the value of x? In one word, what really happens is magic, and it's not an understatement because you won't expect this graph to occur when you iterate value of x for different lambda. So on the x-axis you see values of lambda, on the y-axis you see values of x if you iterate it a long time. So for example, like we saw for x less than 3, it always for lambda x less than 3, x always finds a single stable point. For lambda between 3.1 and about 3.5, it oscillates between 2 points, and then x starts oscillating between 4 points, and then very quickly for 8 points, and even further you can't see it, but x is oscillating between 16 points, and after that it's just chaos. It's completely unpredictable, and the value that x takes is actually used in a lot of pseudo random number generators because it's just so unpredictable. Let's dive deeper into this diagram and see what happens in this particular region of the graph, say between 3.5 lambda and 3.6 lambda. What happens is this thing where you see even more structure. So you see there's this blank regions which were completely unexpected between say 3.58 and 3.59, and then there are further regions around 3.63 which are similar to what we saw in the bigger graph. Let's dive even further. What happens is this tiny little region between 3.57 and 3.58. Again, you wouldn't expect, right? But there is even further structure in this graph. So you see there's blank regions within and smaller blank regions within, and then again the big one that we saw. This almost looks like the entire graph, right, that we saw, but notice that the lambda values is between 3.564 and 3.575, just a tiny region, and it just shows the entire graph again, which I feel is beautiful. It's almost like there is this interstellar intersect, structure within structure within structure, and all that from this very simple equation xn plus 1 equals to lambda xn into 1 minus xn. Who would have imagined it contains so much of structure within it? But what does it all have to do with free will? Let me ask you a very simple question. You see this ball being thrown in this type of a graph, which is called as a trajectory, can you really predict how the ball will move uh, after this blue thing ends? I think it's pretty simple. We have all seen balls going up and down, and balls usually take this sort of a trajectory. So our brains, because they evolved in the real world observing balls being thrown up and down, we can very easily and intuitively calculate the path of this ball. But what about this? The value of x as it's iterated from say 0.0023 for the first 35 iterations. Can you really predict from 35 to 50 iterations what value will x take next? Here are the values that x is going to take. Even though all these look similar, but again at 45 it just starts taking some random numbers again. Again, the point is that this chaotic behavior, this unpredictable behavior, it happens because of feedback cycles. X is taking value based on what values of x previously were taken, and that systems feeding into other systems and themselves is what causes values of x being completely unpredictable. And if this intricate structure is exhibited by such a simple equation, our brain has unimaginable number of feedback loops. It's just trillions of connections amongst billions of neurons, all feeding into one another in some complicated fashion. So prediction of human brain is really an impossible task, even if you know all the underlying laws. So imagine that you knew how our brain, different neurons behave, how they are interconnected, what their activation thresholds are, and really all the neurochemistry, and even at the physical level, even if you've modeled brain to the particle level, prediction of how it will evolve over say reasonably long range period is just almost impossible. And this means when we talk about free will, I feel free will as a word is just tossed without considering what is meant by it. So if by free will you mean to ask if physical laws are deterministic, the answer is yes. The more we discover in physics, the more we find that all physics can be described by fewer and fewer equations. So everything we see around us is deterministic, including quantum mechanics, where the wave function of quantum systems behaves very deterministically. But even if it's deterministic, can you really predict evolution of that equation called as logistic map? No, you just have to wait and watch how it evolves to know what value x will take at the 50th iteration. If you are at 35th iteration, you just have to let it evolve to 36, 37 iteration, and so on and so forth. You can't make a confident prediction of the value of x. Similarly, the logistic map follows mathematical equation, which is simple, and human brain follows physics equations. And so human brains also behave deterministically according to laws of physics. And the answer is yes. But does it mean that can anyone, including like a supercomputer or an advanced alien, really predict how another human will behave? Of course not. We've seen predicting for even a simple logistic map is so difficult, and human brain is just several orders of magnitude more complex than that. And like we said, this is because really we can't even predict value of this little baby. So human brain is just entirely different matter altogether. For logistic map, we just have to wait and watch how x evolves. Similarly, for human brain, we just have to wait and observe how a person behaves to know how they will behave. Everyone knows how they've been surprised by a person who seemed very, very predictable, but one day they suddenly decide to do something that's completely unlike them. And to me, that's like a very big proof of free will. So if anytime anyone asks you, or even if you get this question yourself, do you have a free will? Try to think if you can predict how the logistic map equation evolves, and then ask whether anyone, including yourself, can predict your own behavior. And if not, isn't it isn't it worthy of calling that you have free will? So that's all. Thank you for listening so far. This is my first video, but I hope you enjoyed it. I intend to talk about similar topics. So if you're interested in topics like these, do subscribe. And I'm very active on Twitter, where you can follow me on @Paras Chopra.